Thank you, Patrick, for the introduction, and thank you for the opportunity to present my understanding of this. Very briefly, what I would like to cover is about SME sector in India, about in Asia, and then coming to India, and some perspectives on what can be done to improve energy efficiency. Now, the outline of the presentation is follows: the importance of SME sectors, and I'd particularly like to focus on energy-intensive SME sectors, and I'll explain what that we mean by that, and challenges for upscaling energy efficiency. I think that is the concluding thing in the presentation. Now, SME, the importance of SME already has been told by many of the speakers, and that is very well understood. I mean, it is the backbone of any industrial economy, any country's economy, whether it's a developed country or a developing country. It is, and it provides the employment, large number of employment. It is the major source of employment. And also what essentially SMEs do is use local resources and local entrepreneurship. So that encourages innovation among nations and local regions. It caters, also importantly, it caters to local markets. The products which SMEs make largely cater to local markets as well, and also encourages entrepreneurship. So these are some of the key features about SME and why this sector needs to be looked after and nurtured. Now, specifically coming to Asia, I've got some statistics here how the SME sector is important within economies, Asian economies. For example, in a developed economy like Japan, you can see like SME sector itself, the 98% of the enterprises are actually in the SME sector. And 70% of the employment generation is from SMEs. And even among the Asian tigers like South Korea or Taiwan and so on and so forth, a large employment, 60 to 70% of the employment is from the SME sector. Now, for countries, developing countries like Nepal and Bangladesh, the following statistics: for example, 96% of the industrial enterprises are in the SME sector, and it contributes to more than 80% of employment. So it's a very key sector in developing economies as well as developed economies, and the statistic speaks for itself. Now, coming more specifically to India, again, this also has been mentioned by in the many speakers in the inaugural also, the number of SMEs in the sector, and these are the current statistics: about 44 million SMEs employing about more than 100 million people. Large employment, particularly for the people who have not been access to formal channels of education. I mean, that is a key factor for which actually SMEs provide that. Contributes 8% to the GDP, 42% to exports, and more than 40% to the manufacturing output. So it's obviously a very important sector for the Indian economy. Now, if you look at the characteristics of SMEs, I mean, predominantly we see within the SME sector, there is a large number of micro and small enterprises. Although we call it SME, but typically this is true for most sectors in India. And also what we see is that the geographical clustering, we have clusters, well-known clusters for different SMEs, and there is a huge potential to save energy, about 20 to 40%. I mean, that is the studies what we have done in many sectors prove that there's a huge potential to save energy in this sector. Now, the same fact which I highlighted is actually we've taken example, for example, from the foundry sector, and this fact is brought again reiterated by that factor. Although India, for example, is the third largest producer of castings in the world, it is the next highest producer after China and USA. We see that large number of SMEs, it is basically the sector is concentrated in SME sector. So we have got 4,500 foundries in India, but only about 250 can be classified in the organized sector. So huge number, I mean, more than 90% is in the SME sector. And again, these geographical clusters which I talked about, you can see this map, like you have like 20 well-known clusters. So it is spread all across the country in different pockets. And what is also predominant is that large percentage of SMEs, they are using, in inefficient technologies. There is scope for energy efficiency improvement or improving the processes which these foundries are using. Now, specifically when I wanted to segregate between normal SMEs and energy intensive SMEs, because when we talk about energy intensive SMEs, essentially what we mean here is where the energy cost account for a significant percentage of the cost of production. Where, for example, it can be as from 10%, it can be as high as 30-40% in glass industry. It's a huge so these are energy intensive. It is, I would like to just differentiate between energy intensive SMEs and non-energy intensive SMEs. For example, machining centers or fabrication shops maybe are not a very energy intensive one. And if you look at energy intensive SMEs, then we did a study about, very preliminary analysis of different SME clusters in the country, and roughly we found that there were 15 products which one can classify in energy intensive sectors. For example, these kind of sectors like casting, forging, glass, ceramics, food processing, and textiles, so on, pulp and paper, and so on. And there are within the country there are more than 20 energy intensive clusters. So there would be more, but this is the minimum number. What is important for Indian SMEs, this feature is that large number of products which are made in energy intensive SMEs are essentially for the local markets. So for example, like jaggery or glass bangles, or other food items like khoya or puffed rice, like for example, our friends from abroad may not have heard about such items because these are not there existing in other countries. These are only produced for the local markets. But many of them are very energy intensive. For example, this photograph here is from the glass baking unit. So because they're not produced abroad, these industries don't have ready-made solutions. Unlike many other sectors, probably where the technologies are well developed, one can get a technology from Europe or a developed country like Japan and introduce it here. So there are many such furnaces or applications, and also in waste heat recovery, because one of the themes for that is there. Lot of scope for waste heat recovery and development, research and development in this. And I would like to focus a little bit more on that challenge, rather than, of course, Patrick and other speakers have also highlighted information challenges, financing challenges, and so on and so forth. But I would like to focus particularly on the R&D challenges and in this sector. And coming to the energy intensive SME sectors, what essentially I had highlighted earlier on, because they are using inefficient technologies. So inefficient technologies, for example, age-old practices and technologies which are there for last several decades, 5 decades, maybe 50 years old or maybe 100 years old. The same furnaces, same equipments are used. You can go to many of these units. So conventional technologies and using high energy consumption, also consequently higher emissions or pollution. So that is one of the key features. The second feature is that there have been little R&D efforts to develop cleaner solutions or introduce clean technologies in these kind of SMEs. Primarily because of the following factors. One is the support institutions, the local support institutions which are there, the local service providers which are there. They have not been nurtured in the way it should be. So that is very underdeveloped. And limited capacity, obviously this is well known. Within the industry, they don't have the capacity to invest, nor the funds to invest in new technologies or development of new technologies. Again, low level of awareness is one of the factors, and limited channels of communication. For example, if a technology is demonstrated, even developed in a one found or unit, it is very difficult for it to get replicated without formal channels of communication in this sector. So these are some of the challenges in the SME sector, particularly more specifically for the energy intensive SME sectors. And here I would like to take you through one work we have been doing with support from SDC, the Swiss Agency for Development and Cooperation, in development and demonstration of a cleaner technology for the foundry sector. So basically this essentially the focus and entire thing, actually the project which we have been involved with SDC support involves RD, D&D. That is the entire cycle of research, development, then demonstration of the technology, and then dissemination. So what this essentially has shown, the first important point is that there is a need for finding the right solution, the state-of-the-art technology, or whichever is existing, the knowledge. That's why I've match make the state-of-the-art knowledge, I have put it, not the technology necessarily, to customize or develop local solutions. So, because as I mentioned, technology is not available ready-made in a developed country. So the knowledge which is there can be used to develop this solution for the local industry. And that's why one needs to involve international as well as local expertise for such an R&D initiative. And once the technology is developed, it can be demonstrated in few units, 1 unit, 2 units, or few units in a cluster, and subsequently replicated. Now, when we talk about replication, one of the most important parameter here is, apart from information dissemination, is the hand-holding. Because I pointed out that within the capacity of the sector is not there. So the hand-holding of the SME to replicate that solution is very much important, which is often forgotten in many of the debates. And hand-holding during assimilation and dissemination is one of the key factors. And this particular photograph is from Foundry unit in Howrah, where the demonstration improved furnace, cupola furnace fired by coke was installed. And you can even see the photograph. It's not very clear, but the gentleman from UK who was involved as an international expert, and along with him we had worked to develop this improved version. So the knowledge was used, and the technology concept was there in UK, but the knowledge was developed for the local industry. This is the picture of the unit, entire unit, and what is seen in the background is the older version of the furnace and the pollution control system, which is installed on the cupola. But the view in the front, actually, it has got lot many things apart from the cupola. It has got a bucket charging system, which is actually, it was first time introduced in that cluster in Howrah, because it was till then manual charging. Entire material was charged manually, so this was introduced the first time in that cluster, about 10 years back, more than that. And now this also, there is a pollution control system. That was also an innovation. So we reduced the pollution at source by introducing an energy efficient furnace design, which is called the divided blast cupola, and also treated the pollutants, the flue gas, in the pollution control system, which is a state-of-the-art Venturi scrubber system to meet almost the international norm or the local norm definitely. Now, what we got as a result of the demonstration, we got energy saving, and you can see, for example, we conducted number of energy audits in many cupolas, which was working at that time in Agra and Howrah before we introduced this technology. And this is actually showing the coke percentage which was used by different, the blue bars actually show that, and the green bar actually shows what we got in the demonstration. So even from the best cupola which was operating during that time, which was also a divided blast cupola incidentally, so it was possible to save by an improved version of the design of the divided blast cupola almost 33% coke. And this was achieved in the demonstration plant in the energy performance. And the environmental performance, the pollution control system, Venturi scrubber, this actually brought down the pollution to about 50 milligrams per normal meter cube. That is the smallest bar. And you can see the other bars. Without a pollution control system, the emissions was more than 1,000 milligrams per normal meter cubed. And with the conventional designed pollution control system, that is which you saw, was more than 500. So it was not meeting that norm, and this even the pollution was brought down. And after this, TERI has been involved also in disseminating this to many other clusters. Now more than 100 foundries all over the country, in different parts of the country, are using this design, and we have been providing the technical support, but the furnace is built locally. So essentially what this technology development and demonstration has done is it has created a culture of innovation, if I can put it. And for example, like in this audience also, we have one LSP, local service provider from Firozabad. I have not given that example because of lack of time, but we have also worked in Firozabad among glass foundries, glass industries, and Mr. Sharma, who is here, actually he has, he has been able to sustain that. So building the local, yeah, maybe you can raise your hand. Huh? So the local delivery system and the culture of innovation, which was seeded in the project, has caught on. It's not a sort of a parachuting a technology to a cluster and leaving it at that. So the finals, I would like to make the final points in terms of the challenges which the SMEs face to improve energy efficiency. So the most important challenge is actually to develop or provide the cleaner solution. And this challenge is there across the board. So if there is no technology which is available, commercially available, I mean, you can provide the finance, one can provide the capacity building, but where is the technology from? So that basically the development of the technology is probably, in my mind, one of the key factors in improving the efficiency of the SME sector. The second most important factor is, once the technology is developed, to build the local service delivery system, or build the local capacities. Because as we saw in the foundry, there are 20 clusters, and similarly there are for many other industries also large number of clusters within India. So even if the technology is demonstrated at one cluster, we have to build the local capacities at the cluster level, so that these technologies can be replicated in the large numbers we want. Another factor is hand-holding during dissemination process, because we can't just give the design, for example. Many people ask us only for the design. Now, there are many operating practices which comes with the design. Even if you give the design, it doesn't guarantee that you'll get a most energy efficient system. So the operating practices can be taught only through hand-holding, and these can be done only at the unit level. I mean, some workshops like this is good for information dissemination, but unit level hand-holding would help in the replication of the practices, and that is a long process. And finally, obviously, the regulatory and financing environment. I'm sure the other speakers will cover that. For example, if you have a pollution system, unless you have the regulatory mechanism to implement that pollution norm in place, one cannot, I mean, you can't expect the industry to implement that pollution control system. So the regulatory mechanism, as well as financing, mainly subsidies, incentives, so that industry can go for these cleaner technologies. And why you need subsidy is one of the most important factors. Is any clean technology, that is what I believe, would be more expensive than the conventional. So the entrepreneur won't go for it immediately. You need some subsidies for the entrepreneur so that they can go for that. I think I'll close it that. Thank you very much for your attention. Thank you.